Hello, this video is about implicit differentiation. We use implicit differentiation when we take a derivative of an expression that is not solved for the y. All the questions so far have been solved for the y. So here is one example. And the question is, find the derivative of this function. And this function is called y. So let's call this function y equals. And the question is, find the derivative. Now, there are two notations for taking the derivative. And the one we have used so far is Newton notation. And Newton notation is developed by Sir Isaac Newton, and it involves these tick marks, which are prime. So when we asked y prime, we are asking for the derivative of y. And so what that Newton notation means is we're applying the derivative to both sides, and we're taking a derivative of y, getting y prime, and then we're taking a derivative of each term of our function, and the derivative of x squared is 2x. Using the power rule, the derivative of 25x is just 25, and so our final answer using Newton notation is y prime equals 2x plus 25. Now, about the same time as Newton was developing calculus in England, Leibnitz was developing his version of calculus in Germany, and he used a different notation. We use both of these notations in the calculus class. Leibniz notation is using the differential operator. The differential operator is d with respect to something. So this means derivative of something with respect to some other function. And it could be x, could be y, could be t, could be anything. So let's solve the same exact question using the Leibniz notation to see how that would work. So let me rewrite the question first, and then we will apply the differential operator to both sides and see how that works out. So now we're using Leibniz notation, and we're applying the differential operator to both ends. Just like we were applying the prime to both sides in Newton notation, now we are applying the differential operator to both sides using Leibniz notation. Now here the derivative of y with respect to x is just dy dx, and the dy dx is known as y prime. So each time we see y prime, that is equal to dy dx in Leibniz notation. Now on the right side we have the derivative of x squared. Now what is the derivative of x squared? That's a power rule, and the power rule says the derivative of x squared is 2x times, by chain rule, the derivative of the inside function. The inside function is just x. So applying the differential operator to the x with respect to x, well, dx over dx is 1 because it's the same exact expression, top and bottom. So this equals to 1 plus, now applying the same differential operator to distributing it to the 25x, we have 25, let's put 25, and then dx over dx, which once again is equal to 1. So here we have y prime is equal to 2x plus 25. So both our answers say here is 2x plus 25, here is 2x plus 25. The difference is in notation. Now, when we use implicit differentiation, we use Leibniz notation. And the thing to remember here is each time we take a derivative of y, the variables will not cancel off because the y and x do not cancel. It gives us y prime. So each time we take a derivative of y, we will need to multiply by the y prime. And each time we take a derivative of x, we don't need to do that because dx over dx cancels off. Now let's look at a different example. This example was solved for the y. The next example is equation of a circle with radius of 25. It can be solved for the y because we can move the x squared on the other side and take square root of both sides. We'll have two functions to work with, but it can be done. We could also use the implicit differentiation to find the derivative and not solve anything for the y. So let's use implicit differentiation in Leibniz notation to solve this. We will then do it in Newton notation to show how that works. So in Leibniz notation, we apply the differential operator to both sides. So d dx to the x squared plus apply d dx to the y squared, and then apply the same operator to the 25. Now, the derivative of x squared is 2x times dx dx, because the derivative of the inside function is x, so derivative of x with respect to x, plus the y squared, the derivative of y squared is 2y times dy dx, the derivative of y with respect to x. On the other side, there is no x. So what is the change of 25 with respect to x? There is no change. The derivative of any constant is 0, and so we have 0. Now, the dx over dx is 1. That cancels off, leaving us with 2x plus 2y times dy dx. And we're looking for the derivative of y, which is named dy dx. So all we need to do is solve our equation for dy dx. And that means move the 2x on the other side. On the right side, we have 2y equals negative 2x. And then dy dx also. And so to cancel the times by 2y, we divide both sides by 2y, and we get dy dx is equal to negative 2x over 2y. And that's how to use Leibniz notation to take a derivative using implicit differentiation. We could have also done the same question using the Newton notation, but simply remembering to add times y prime when we take a derivative of the function y. So here, let's do the same question using the Newton notation. Since both of these notations can be used, it is the user who decides which notation is better for the person. It may be easier to simply take the derivative using the Newton notation. And remember that the derivative of x squared is 2x, and the derivative of y squared is 2y, but each time I'm taking derivative of y, I need to add y prime. And the derivative of 25 is 0. At this point, we do the same exact step. We minus the 2x from both sides, giving us 2y times y prime is negative 2x. Dividing both sides by 2y, we get y prime is negative 2x over 2y. We could also reduce by 2 and have our final answer that y prime is equal to negative x over y, which is the same as we have using the Leibniz notation. So this is Newton answer, Leibniz answer. Both are the same. Now sometimes the function actually depends, the variables depend on the different variables. So this x actually depends on the time. Excuse me, and this y depends on the time. So we have 2 points, x and y, that actually move in the space. And the question is, find the derivative of y when the point is located at 5 square root of 2 over 2, 5 square root of 2 over 2, if the dx dt is negative 1 inch per second. So the formula, if you notice, is exactly the same as we have solved before. This is x squared, y squared, 25. X squared, y squared, 25. Both of these are equations of a circle. This circle is stationary. Nothing is moving on that circle. This circle, the point is actually traveling on the edge of this circle in the counterclockwise direction. So right now, we are at this point here, which is 5 square root of 2 over 2, 5 square root of 2 over 2. The angle is 45 degrees, and we are right here. So the question is asking how fast is the y changes as the x, so this is the y changes, as the x is changing with negative 1 inch per second. So the x, this is the x is shrinking with the rate of negative 1 inch per second. So as the x gets closer and closer this way, what happens to the y of this point? And the y is going up at some speed. The question is how fast, and that's the what we have to find. So let's use the notation. We will use the Leibniz notation to do this. So this time we take a derivative with respect to time. So we apply the d dt, derivative with respect to time, to the function x of t squared, plus d dt to the function y of t squared, and then d dt to the 25. And the answers are exactly the same. The only difference is now the derivative of x squared is 2x times the derivative of the inside function with respect to time. Well, the inside function is dx with respect to time. And here we have 2y times dy with respect to time. And the derivative of a constant is still 0. So the dx dt is the same as x prime. And the dy dt is the same as y prime. So we're asked to find the y prime. So let's solve this question for the y prime. Y prime is, we move everything that does not have y prime to the other side, which is negative 2x times x prime. And then we divide both sides by 2y to get y prime by itself. We can reduce by 2's, and we have that y prime is equal to negative x over y times x prime. Well, what is x? X is 5 square root of 2 over 2. Y is 5 square root of 2 over 2, which is exactly the same number. If I put that in, I will have y prime is 5 square root of 2 over 2 divided by 5 square root of 2 over 2 times the x prime, which we know is equal to negative 1. Here is x prime, negative 1. So the same number over the same number cancels, gives us equal to 1. And here I have my answer. I have a negative here. There is a negative here. Two negatives make a plus. So the answer is y prime is simply equal to 1, which is 1 inch per second, which means our height is increasing at the rate of 1 inch per second at the time when the point is at 45 degrees and the x is changing at the rate of negative 1 inch per second. So this is using the implicit differentiation to solve a function that has t's in it. One last example. Let's use Newton notation to take a derivative of this function. It is not solved for y. We cannot solve this function for y, even if we wanted to. The only approach is implicit. So let's apply implicit differentiation. So here we will take 3x squared y plus 5y squared. We'll take a derivative, and then we'll take a derivative of the other side. So taking a derivative of 3x squared y, what rule would we use? And what rule would we use when we take a derivative of 5y squared? So here, the derivative of 3x squared times y, that's a product rule because we're multiplying two different functions. So using the product rule, what would it say? Well, the product rule says we take a derivative of the first, that's a derivative of 3x squared, times the second, plus skip the first and take a derivative of the second, plus. Now the derivative of 5y squared is 5 times the derivative of y squared, which is 2y, times, by chain rule, the derivative of the inside function, which is y prime. The derivative of 8x is just 8. So we're almost done. We need to take a derivative of 3x squared, which is 6x y plus 3x squared y prime. 5 times 2 is 10 y. Y prime is 8. Now we have y prime in two terms, and this term has no y prime. Let's move it over to the right side. So we have And in the same time, we will factor out the y prime from these two terms. So taking y prime, we have 3x squared plus 10y. And at the same time, we're subtracting 6xy from both sides, making y minus 6xy. The only thing left to do is to undo multiplication. So we divide both sides by 3x squared plus 10y. What we're doing on one side, we're doing on the other side, plus 10y. These cancel. And our final answer is the derivative is equal to 8 minus 6xy divided by 3x squared plus 10y. And that's the final answer to our last example. That's how to use implicit differentiation on a function that is solved or not solved for the y. If you have any questions on anything, please let me know. Thank you for your time.